Hi, everybody. This is Math 111, Section 10.2 Notes, page 6. In 2000, 58% of females aged 15 or older lived alone. That seems like a high number to me. A sociology wishes to test this percentage and see if it's different today by collecting a random sample of 500 females, 15 or older. She finds that of those 500 females, 285 are living alone. Is there sufficient evidence at a significance level of 0.1 to conclude that the percentage has changed? Not whether it's higher or whether it's lower, but whether it's different. First, we have to test this for normality. So our first test for normality is we take 500 from our sample and divide it by n, the total number of females in the entire population. And I'm not sure what that number is, but I know that it's huge, and 500 divided by huge is going to be smaller than that. So the first test passes. The second test now we're going to test and see if this portion of it passes. So we just got to take our 500, the old average 0.58, 1 minus 0.58 or 0.42, and that's going to be 121.8, which is greater than 10. So it passes both those tests. We can assume that this is things close to normal, so we can use our formulas. Write the null and alternative hypothesis for this. Well, the null hypothesis is that the probability is 58% of these girls live alone at the age of 15 or older. And then this is our alternative hypothesis. It's not greater than, it's not less than. We're just saying that it's not 58% anymore. It's changed. So this is a two-tailed test. Finding P when it's a two-tailed test is a little trickier. What we have to do is, if we're 90% sure, that goes in the middle, and 10% is divided up equally on either side. We need to find the area bounded by the curve and the x-axis all the way up to that spot, and then double it. So we're only going to do part of the problem and double it for our p-value. Okay? So to find p-value using a two-tailed test, we need 4 values and our TI-36X Pro. The filled-in notes guide you through how to use a TI-83 and 84 calculator, and this is how we have to do it with our calculators. So we need the population mean. That comes from the original problem, 0.58. That's what mu is. Sigma is the next thing that we're prompted for on our calculators, and that calculation shown there. The next prompt is the lower bound, and we're just finding this portion, and then we're going to double it. So that's negative infinity. And then the upper bound is our calculated new sample mean. The new sample mean is, of those 500 ladies, 285 of them are living on their own. Does that make sense, guys? So let's fire up our calculator. Let's put in these values and then see what we get. And remember, we're only calculating half of the two-tailed tests. So far, this looks like we're doing a one-tailed test, and then we're going to double it. So turn your calculators on. Well, for heaven's sakes, my values are sitting in here from the last time I did a problem. Go into the distribution menu, so shift to data, slide over to distribution. We want to find the normal CDF. That's another way of calculating the p-value. The mu, or the population mean, that was from the problem, 0.58. Put that in there. The sigma, I've already pre-calculated it, but if you don't want to pre-calculate these things, you can put them right into the formula. So I'm going to do it that way to keep better significant digits. It's the square root of p, 0.58, times 1 minus p, 0.42, divided by N 500. It'll calculate that value and stick it in that spot. Boom. Next, the lower bound is negative infinity. Any negative value smaller than -1 would suffice. And the upper bound. The upper bound is this new sample mean, or the sample average. So we're going to put this 285 over 500 right here. Again, if you want to calculate what those values are in advance, you can, and then put them in those 4 prompts. When we calculate that, hit it, we get 0.3252. And if you're following the filled in notes, that's what they have. And then you have to double it. So we're going to take that last value that gets computed with your calculator and take it times 2. Easy for me to say. And when you take it times 2, 0.6505. And that's how you do it, 0.6505. Since the p-value, 0.6505, is greater than our confidence level, 0.1, we fail to reject the null hypothesis and say there's no significant change. What would happen if the significance level changed to 95%? I'm 95% sure that this thing's changed. Well, that's going to make it worse, okay? We went the wrong direction if we want to accept or not reject the null hypothesis. So this 0.6505, don't have to do that computation. It's the same exact value, but now we're comparing it to a even higher confidence level, okay? This value shrunk down. So it's also greater than this. So we fail to reject this null hypothesis for a second time. Guys, I hope this is helpful. Try them on your homework. If you miss it once or twice, then shoot me an email with the exact problem, and hopefully I can help you out. We'll talk to you soon. Bye-bye.